Welcome to my YouTube channel. Today, we'll be taking word problems on permutation. As you can see on the screen, if you have been following our class, in our last class, we were able to treat some questions on permutation, but not a word problem. And we promise to start this class with word problem so that we'll just interpret it normally so that we can solve it the way we solve our question in our last class. Let's dive straight into the question. Question number one says, calculate the numbers of permutation there are of a 5 distinct objects taking 2 at a time, 4 distinct objects taking 2 at a time. So let's go straight to solving the question. So question for solution number one. First thing first, if you remember our formula, we're able to establish that n permutation r is n factorial all over n minus r factorial. That is our formula, if you remember. So the next thing for us is to establish from this question what our n permutation r is. So we bring it down here. So we need to establish what our n permutation r is. So from that, we'll be able to solve ahead our question. Very important. So with that, let's go. We can now say the question says calculate the numbers of permutations there are of 5 distinct objects taking 2 at a time. By implication, it is very key. We understand that this means 5 permutation 2. 5 permutation 2. So I can now say this is what? 5 permutation 2. So we can, with this, we know our n, we know our r. So our n is 5 and our r is 2. Very good. So with this, we can now say our 5 minus 2 here will give us what? 3. So here we have 3 factorial. Awesome. So with this now, I can also forge ahead. We can answer our 5 permutation 2 to give us what? If we bring this, I'm sure we still remember that factorial means you will multiply all through to the end. A quick reminder, 5 factorial means 5 times 4 times 3 times 2 times 1. That's the meaning of 5 factorial. And 3 factorial means 3 times 2 times 1. Awesome. So with that, we can now say our 3 times 2 times 1 can cancel out 3 times 2 times 1. So our 5 permutation 2 will now be 5 times 4 to give us what? 20. Awesome. So that's for A. Now for B, we are asked that we have to calculate the number of permutations there are of 4 distinct objects taking 2 at a time. 4 distinct objects taking 2 at a time. So let's just take what we have here as a template. Four distinct objects taking 2 at a time by implication. That means 4 permutation 2. Very good. So we can call this one our B. can call this our B. Very good. Awesome. We can call this one our B and can call this our A. Very good. Awesome. So now the question says 4 distinct objects taking 2 at a time. That's 4 permutation 2. So let's just edit what we have here to be what? 4 permutation 2. So by so doing, we have 4 factorial here. Here we have 4 minus 2 factorial. And 4 minus 2 naturally give us what? 2. So having done that, 4 permutation 2 will now be what? 4 factorial 4 factorial over 2 factorial. And we know our factorial now to be what? 4, our factorial to be multiplying through to the end. Multiplying through to the end. We are used to that. Multiply through to the end. 4 factorial is 4 times 3 times 2 times 1. And our 2 factorial will be what? 2 times 1. Having done that, that means our 2 times 1 can cancel out our 2 times 1. So we'll be left with what? 4 times 3. So our 4 permutation 2 simply give us what? 4 times 3 is what? 12. Awesome. So that settles for question number 1. Now let's dive straight to question number 2. Question number 2 says calculate the numbers of permutation there are of 15 distinct objects taking 2 at a time, 9 distinct objects taking 4 at a time. So for this, it will be 15 permutation 2. So for question number 2, A now. Let's get this as a template. To help us. Okay, let's make do with most of all we have here. Always edit them, make use of it as a template. So we can say this is our number 2A. Awesome. So if this is our 2A, the question says 15 distinct objects taking 2 at a time. So that is 15 permutation 2. 15 permutation 2. So we now have it here. What? 15 permutation 2. So up here we now have what? 15 factorial. Down here we now have 15 minus 2. So 15 factorial. 15 minus 2 will give us what? 13. Very good. So our 15 permutation 2 will now be what? 15 factorial will be 15 times 14 times 13 times like that till to 1. So we can simply say, okay, let's see what we can do. 15 times. Okay. Awesome. So 15 times 14 times 13 like that. It will continue like that till we have times 1. So we have 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is 15 factorial. And down here we have 13 factorial. That means we have 13 times 12, 13 times 12 times 11, like that. So let's make do with what we have here. So we have 13 times 12 times. We will continue till we have times 1. Awesome. So with this, we can now say our 13 times 12 times 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. We cancel what we have here. 13 times 12 times 11 times 10 times 9, 8, 7, 9, 8, 7, 6, 5, 4, 3, 2, 1. We cancel out. So our 15 permutation 2 will now be left with what? After we cancelled 13 to 1, we left with 15 times 14. So if you bring out our calculator and punch 15 times 14, it gives us what? 210. That is for 2A. Now for 2B, let's get this template. The question says 9 distinct objects taking 4 at a time. 9 distinct objects taking 4 at a time. That is 9 permutation 4. So let's get this as a template for our B. So we have our 2B here. Awesome. So 2B says what? 9 distinct objects taking 4 at a time. 9 permutation 4. 9 permutation 4. So here we have our 9 permutation 4. So with that, we now have 9 factorial here in our formula. Here we now have 9 minus 4 factorial. So bring out our calculator. 9 minus 4 will give us what? 5. So we have 5 factorial at the denominator here. Awesome. So as usual, we know how to calculate our factorial. So 9 factorial divided by 5 factorial. Awesome. So with this, let's get templates. So our 9 factorial will now be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Very good. And 5 factorial will be 5 times 4 times 3 times 2 times 1. Awesome. So having done that, our 5 times 4 times 3 times 2 times 1 will cancel out 5 times 4 times 3 times 2 times 1. So our 9 permutation 4 will now be left with what? 9 times 8 times 7 times 6. If you bring out your calculator, you punch 9 times 8 times 7 times 6, you'll be left with what? 3024. 3024. That's our final answer. Interesting. So you can always pause and rewind this video for clarification and understanding. Very easy and straightforward. And don't forget to subscribe to this YouTube channel, My Simple Maths, and always press the notification bell beside so that you can get notification of new videos from us whenever we post it. Thank you.